we now understand that organic reactions involve reactions between nucleophiles and electrophiles, intermediates or species that act, if you like, or serve as electron donors that react with other species or sites that require electrons and therefore electrophiles. So, but why do organic reactions take place to start with? Well, one reason why organic reactions take place is the attraction between oppositely charged species or intermediates. So that's one reason. Let's take, for example, a reaction between the azide ion and this alkyl iodide. So why do these reactants react with each other? When you mix these two, they bump into each other, they collide, if you like. But why do they react? Well, that's because of the attraction between the negatively charged nucleophile and the positively charged carbon, which has a partial positive charge due to the polarizability of that CI bond. So attraction between charges, if you like, or dipoles is one reason or one mechanism by which organic reactions take place. If this reaction takes place, we get the product, which is that one. So this is a typical SN2 type reaction. This reaction is actually of substitution type, specifically is SN2. So the azide ion will come and attack that carbon, and the CI bond simultaneously break. It has to break at the same time. This is typical SN2. We will see substitution reactions later on. So attraction of charges as one mechanism or one way by which or for which organic reactions take place. But organic reactions may not always be as an attraction between charged species or charged intermediates. Let's take, for example, a classical reaction, a reaction between an alkene in general, for example, and bromine. You've seen this reaction in the test for functional groups. If you like, this is actually an unsaturation experiment to test for the presence of carbon-carbon double bond. Now, this nucleophile, or this is actually the nucleophile, it's uncharged, and this electrophile is also uncharged. Okay, but why does the reaction take place anyway? Now, it's not an attraction between oppositely charged ions, if you like, or oppositely charged species or oppositely charged intermediates, but it's actually a reaction between a filled orbital in the carbon-carbon double bond and an empty orbital in the XX bond, the BR-BR bond. Specifically, we are talking about orbitals here. We are talking about frontier orbitals here. This example or this reaction is an example of an organic reaction where it involves a reaction between a full orbital in the carbon-carbon double bond and an empty orbital in the BR-BR bond. We are talking about basically the HOMO-LUMO overlap or HOMO-LUMO interaction. So it is actually the HOMO from the alkene that reacts with the LUMO in the BR-BR bond, the HOMO in the nucleophile with the LUMO in the electrophile. It's the HOMO, the highest occupied molecular orbital. It's a full orbital that overlaps with an empty BR-BR anti-bonding orbital. Is actually sigma star. So it's a sigma star orbital, and it's a full pi orbital. In this case, the HOMO-LUMO interactions or the HOMO-LUMO orbital overlap is the foundation, if you like, or the underlying principle behind the reaction of typically alkenes with halogens. So the product is actually this, which is an addition product where the carbon-carbon double bond has been broken and the electrophile, if you like, adds to it. So this is an addition reaction. It's a typical example of an addition reaction, specifically electrophilic addition reactions to alkenes, because the alkene the halogen adds to the carbon-carbon double bond. So that's an example of, or another way, if you like, why, or another reason, if you like, why organic reactions take place. So the first example illustrates the idea of the attraction between oppositely charged intermediates. The second example is a reaction between a filled orbital. So we can also write that down. This is a filled orbital with an empty sigma star orbital. So that's another reason why organic reactions take place. But again, these have to overcome the activation energy, obviously. These have to be thermodynamically allowed. They have to outweigh, if you like, the repulsions between filled orbitals. And again, to wrap this up, organic reactions take place due to attraction between charged ions or charged intermediates. The other reason is overlap between a homo-orbital, a filled orbital in a nucleophile with an empty orbital or a LUMO orbital in the electrophile.